be talking about ship construction, in particular Niagara, and this is just the start. We're kind of going to be building and using kind of the basic terms. So today we're going to introduce some of the terms of the key structural members of the ship. We're going to be pretty broad and general with them. We're not going to get too much in detail with the various parts, but want to kind of just go over the key structure. And then we're going to be introducing and discussing some of those parts. So some of the terms that we're going to go over, we'll be talking about the keel of the ship, which is the main longitudinal timber, which really is the beginning and the support for the hull. Then we have the frames, which are transverse timbers. And there's many frames throughout the structure of the ship and really give the ship its shape. We'll talk a little bit about futtocks, which are the kind of components of the frame, in particular a double sawn frame. And the floor timber is a term used to describe the part of the frame that is there at the keel, creating kind of the floor at the bottom of the hull.
Captain.
Yeah.
Don't mean to butt in right now so early with questions, but how many frames does Niagara have?
We'll see. We actually have a photo that will tell us.
Oh, cool.
So then we have the keelson that we'll take a look at, which is another internal longitudinal timber, which goes on top of the frames. It kind of locks in the frames and the keel together. Then we have the stem, which is a kind of an upward timber coming off of the keel, creating the bow of the ship, where all the other structural members are going to be built off of. Then we have the stern post, which is the vertical timber back aft for assembling the transom. Then we have the waterway timber, which we'll talk about, which is a longitudinal timber at the deck level, which ties all the frames together. We'll talk about scarf, which is a type of joint for putting two timbers together. And then we'll talk about lamination, which is the gluing of layers, and then double sawn frames, which is a general term for frames that are composed together in two rows, which overlap in futtocks. So first, real quick, a scarf. Like I mentioned, it's an overlapping joint used to connect two timbers. Most of the repairs of, say, the waterway on Niagara and other large repairs that where if you're going to have a large structural member, but you're not going to have say a large whole tree that you can use for it, you can glue or laminate and epoxy these joints together to make a whole piece. And this is often done for large, like I said, longitudinal pieces or parts to put two timbers together. You have different types of scarves, which we won't get into. But the most basic is the plain one that's pictured here on the left. But you can get different types of notches and wedges in there to help kind of keep that scarf secure.
So we're seeing with the tabled scarf there's some sort of wedge in there?
Yeah, exactly.
Okay.
Right there in the middle, yeah.
Are these, Captain, normally just glued together, or can you use bolts or that?
They're normally going to be glued together, but if it's a very large scarf and a very structural part or structural timber, then you would also likely use a bolt or some type of fastener.
Okay, thank you.
Yeah. Lamination. This is one way of creating large structural timbers, like say a mast or a keel, or a frame. When you don't have, wood or logs or trees that will actually be large enough to give you that structural member. So you can glue layers upon layers together to create the size and length that you need, or shape that you need for different types of structural members or parts of the ship. So this is Actually, majority of our structural members are going to be laminated in some way. And majority of our, the keel, the frames, the keelson are going to be laminated yellow pine. So like we discussed during morning muster, we have these major components here. So everything begins with the keel, the lower part of the ship there. So we have our keel down here. Then we have our frames, which are made of futtocks. So the futtocks are the different components of the frame that we'll take a look at a little bit more in depth. Then we have the keelson, which lays on top of the frames and ties all of them together with the keel. And then we have the waterway timbers that lay on the deck beams and tie in the frames together with the deck beams as well. So starting with the keel. Yeah, go ahead.
Question.
Yeah.
The historically, pine was used in ships that were not meant to last long. I mean, it's sort of the cheapest material you could use. Why is the Niagara built in yellow pine? Same reason?
No, so I mean not the modern one, right? So yes, you know, when you go to your hardware store, you buy pine. Generally, it's going to be the cheaper of the two, but pine, spruce also are very resinous in terms of the tar or the sap that they have. And so when you're laminating them together and you have a very type of lumber that has a lot of resin in it or sap, that actually does help with rot prevention. And these are also all glued together in various ways to keep them, make them structurally strong as well. So, but they're also light, lighter than say your heavier woods, like say an oak. So that would be why I would say that they're using yellow pine there, is because of the amount of sap or resin in it.
Okay.
That's particular for the frames as well. So here we have the keel. Like we mentioned before, the keel is kind of the basic kind of building block here of the ship structure. So we have our keel here, our frames. It says floor here. So that's one of the timbers of the frame. Is one part of it is called the floor, the part that goes across the keel, and then the other parts that go upwards as they interlocked are called the futtocks. And then tying on top, we have the keelson. A couple of things that I'll just throw out there right now. You can see where the garter plank or the hull planks here come into the keel, where it gets cut into the keel or other parts of the structure to allow the planks to lay in there. It's called a rabbet. Talking about frames here. Here's some good examples of this is Niagara. She's being built. And so Niagara has double sawn frames, which we'll take another look at in the next slide here. But the futtocks, like I mentioned, this is a little easier to see now. But you're going to have different sections that are put together to allow you to create this shape but still hold the strength. And their butts, or the ends of them, are all staggered. And you can see how the frames all come together and go on top of the keel here. And so this numbered area here, this is the keel. The frames are getting laid on top of. Connected to. And then you can see the supports that they're putting in place here as the ship is, all the frames are being put in to help support those frames until the rest of the structure is in place. As soon as they can get the keelson on, and obviously deck beams and waterway and all the other parts that makes the structure. And then, like I mentioned, the floor timber is going to be the actual part of the frame that is the part that lays onto the keel there. It creates the floor of the inner hull. Here we can see the frames when they're being either constructed or waiting to be constructed. You can see the different grains being used. Particular right up here. So the frames are laminated together to allow them to build the curvature and the shape of the hull. Here we have the
Does
inner hull.
double sawn mean that they're laminated?
No, so you can have double sawn and not laminated. Laminated means you're glued together with pieces on top of pieces. So you can see different pieces here.
Yeah.
Yeah. So that's what the laminated part means. The double sawn part, hopefully you can see there's a section here. I can't quite see where the line is, but I think it's about here. So that's one part. Then you have another part that's like right here.
Oh, okay. I understand now.
So
Thanks.
there are now, yeah, two parts laid next to each other.
Got it.
So here are the keelson, the internal longitudinal member there, laid on top of the frame. So these are all frames, and you can see anyone have a guess of what way we're looking right now? What way we're facing?
We are looking towards the stern.
We are. So the kind of the extreme curvature there of the frames, that's going to be where the transom is, and that's going to be the counter of the stern there, or the counter to the transom. So the area that the ship, the after part of the ship overhangs the water. It actually isn't in the water.
I would also like to point out, just from modeling experience, planking that area is hell.
Yeah, whenever you got lots of curves, planking is going to be much more difficult. You can imagine when you're going from the model to a size of a ship like Niagara, it's also very difficult.
Yeah, because the planks I have are like a 32nd of an inch. I'm imagining these ones are what, 6 inches thick?
Not too far off.
Yeah.
But it's another internal structure here that, again, longitudinal support.
Captain,
Yeah.
the ballast, would that be along the keelson or the keel?
So the external lead keel is put on outside of the keel, so outside of the ship, so lower below the keel. There is internal ballast that is put in the bilge, and that would be not necessarily here yet. It would be put on top of the frames, not the frame, sorry, the ceiling. So next week we'll start to be talking more about other internal structure members in the ceiling. In the left here, I believe they're installing parts, or starting to install part of the ceiling planks here. But the ballast would be as low as you can put it after the ship is completely built. So it'd be closer to where the keelson is, kind of more to the point of your question.
Okay, thank you.
Yep.
Captain, you said some,
Go ahead.
you said some ballast would be on the keel itself. Is that correct?
Yeah, that's the external lead keel that was installed to add more weight and lateral resistance to the ship to sail.
Would that be between the keel and the false keel, or would that be at the bottom of the false keel?
That would be below the false keel.
Thank you.
So here we're looking at the stem. So to the right is a drawing from a clipper ship that I was able to find. And then on the left is actually a picture of Niagara's stem being built. And the stem is sometimes referred to generally as that part of the ship, but is it also a specific timber, which we're looking at right here. So this is the stem there. And in the drawing, it's signified right there.
This would be the bow.
This is at the bow, yeah. So the stem is that vertical timber that the bow structure is being built off of. And there's a fun one. It's called an apron right there. Apron right here as well. It kind of like a knee that helps support the stem as it connects to the keel there. It's kind of an internal stem almost to the outer stem. And maybe you should be able to see here. I'll highlight it. But right here, if you can notice, the frames don't go across. They actually go right just to the keel itself. And these are called half frames. So the frames don't go all the way through. And this is going to happen at both the bow and the transom as things get tighter and tighter and closer together. Then on the other side of the other end of the ship, we have the stern, the transom. We're talking about the stern post. This again is another vertical upward curving timber that the transom is built off of. So here we have the stern post. And as you can see, many different parts and components here. But ultimately, it's all built off the stern post. You have a stern knee, inner stern post. Here we can see the keel here.
Captain, what are those markings on the orange thing?
So the orange thing is the keel, and those numbers are the frames. So where we were talking, you had the question of how many frames there are.
106, apparently.
Yeah, about 90, 96 there. Now, they haven't finished the transom here. So there's probably going to be some additional, I think it goes all the way to probably 102 there. Looks like I can see in the drawing they have some markings for the last few frames that come in here at the transom. And the numbering, you'll see these are all even. That's because we're on the port side. All the frames on the starboard side are going to be odd numbered. And that's going to be the same way we number anything on a ship. When it's on the starboard, it's odd. When it's on port, it's even. The waterway timber. So here we're looking on deck. So you can see up here on the upper picture here where this is the waterway timber, where it's being fastened to the frames, which are the vertical timbers here. And then we have along the deck, we have the waterway timber here running along both sides, and you can see how it goes all the way to the transom. And those are laying on top of the deck beams, which are going to support the deck planking and create the support for our hatches structure there. Then in the picture in the middle here, we can see the bulwark planking being put in place. And then we have our waterway timber there running the length. And then on our lower right, we have it all completed and painted. In a different color than we use now. Since we generally the bulwarks on either side are either green or red. And then on the far right there, you can see we have a shipwright who is recalking the deck because part of the deck had to get removed as the waterway was demoed, and then a new parts scarfed in. And then kind of just a quick review in terms that we talked about: the keel, the frame, our keelson, and they're really kind of the keel frames and the keelson really make the kind of the main structural part of the ship here. They give it its strength, and everything is built off of that. And then you can, my little drawing here, my diagram, you can see different parts of the frames being the futtocks, and then the lower part, or the lower timber that crosses the keel, is the floor. All right, so that's what I have for us today. Anybody have anything they want to review or questions they want to ask?